Hello everyone, my name is Willemijn van Rooijen, and in this presentation I will present the poster that we made for the Energi Simulation Summit. So my poster is in the topic of underground hydrogen storage, and I hope you are all familiar with this, but if you are not, the basic idea of underground hydrogen storage is that we store hydrogen, in this case on a seasonal basis, in the subsurface. And by doing this, we hope to resolve the problem that we will have later on with the energy transition. Because if we will produce more and more renewable energy, there will at some point be a disbalance between the energy demand and the energy supply that we have. And if we store this on a seasonal basis, we can resolve this seasonal disbalance problem. But imagine, we finally did all the research that we need. We are ready to implement this technique of underground hydrogen storage. But we have to decide, where do we store this hydrogen? We already know that based on the seasonal disbalance that we have, that we need very large volumes. And for that, a very likely solution will be storing it in depleted oil and gas fields. But the problem is there are so many oil and gas fields. In the Netherlands, we already have almost 500 depleted oil and gas fields. So to solve this, we are working on a multiscale framework for reliable and efficient site selection for underground hydrogen storage. So the site selection method, I will zoom in a little bit, will consist of 3 stages. In the first stage, we put all the sites on a list, basically, and based on readily available data and based on site selection criteria that we will develop, we can eliminate the fields that we already know are not good. Then we take the fields that are not eliminated to the second stage, and also based on readily available data, we want to rank all the sites. And for that, we also use site selection criteria. Then we choose a few of the top ranking sites, depending on many factors. And at those top ranking sites, we will look at a lot more data. And we will also maybe do some more research, and we will do yield modeling so that we can make real predictions for this specific site on efficiency, but also on the economic side of it. And of course, we also have to look at locations and social aspects, and taking all that in mind. But you already heard me say it maybe a few times. We need site selection criteria. And how do we come up with this site selection criteria? For that, we will use what we call multiscale simulations. And the idea of these multiscale simulations is that the simulations itself will be on the kilometer scale. But from all the research that we did over the last couple of years, we know that there are many other scales, like smaller scales, that play an important role. And then we want to use all the recent but also most reliable data to come up with accurate predictions on these very large scale, taking the small scales into account. So I want to highlight a few components of our reservoir scale simulator. And the first component I want to look at is the input of molecular simulations that we have. So before we did molecular simulations, and in these types of simulations, we look at the movement of individual atoms. And from the movement and the interactions that these atoms or molecules have and the force fields that they use for that, you can gain a lot of interesting data like diffusion, dispersion, interfacial tension. And you might think now you can also measure this in the lab, and that is true, and we definitely need this data for validation. But everyone who ever did lab measurements know that there are always a lot of challenges involved, and especially if we look at the conditions where underground hydrogen storage is dealing with, we need to understand all the properties at high pressures, high temperatures, high salinities, and also over a wide range of conditions. And with the molecular simulations, once you've validated the data with experimental results, you can do the simulations for all the conditions that you like. So over here, we show some of the results for interfacial tension, which is just an example. So the crosses represent experimental data and the squares represent our data. And you can see that we have quite a close match. It's everywhere, it's less than 10% difference. But since we were able to create so many data points, we we have a very good sense of how the interfacial tension will differ over pressures, temperatures, and also in the range that we will actually use it. Well, of course, this is very useful for the very small scale properties, like nanometers is the scale that we look at. But if we look at larger scale properties, like the core scale range, like the centimeter scale, we do need laboratory measurements. And from literature, we know that hysteric relative permeability data and also capillary pressure data is very important. We saw some examples how it can differ if you use generic relative permeability data, or if you focus on the wrong gas, for example. And that is why we will look in a lot of detail at all the data that is available. How will hysteresis play a role? What will actually be the most suitable model to use in which case? Because also the pore scale structure can make a huge difference. And how will this in the end play a role in the site selection criteria that we will develop? And then the last part where I want to focus on is the relevant physics and thermodynamics. It sounds very logical. Of course, this is very important. But underground hydrogen storage can be quite challenging in the sense that we will have a cushion gas most likely present. We will have gas mixing. I was just talking about all these important input parameters that we gained for hydrogen. Well, actually, maybe a bit part of the simulations will be a mix between hydrogen and the gases that are already present or that we use as cushion gas, like methane, hydrogen mixtures. And how will the thermodynamics impact the behavior of those gases? How will the solubility be impacted by the gas mixing, and so on? Well, using all these different inputs and all the lessons that we learned in the past from all the research that we did all together, we want to combine this all into a reservoir scale simulator. And by doing sensitivity analysis, we're looking at different types of fields. We will come up with a site selection framework with new site selection criteria. There are already some in literature, but we want to add some more. And we want to apply this to all the 500 almost Dutch fields that we have here in the Netherlands. And there are, of course, certain aspects where you should look at. And the four main sub-criteria that we will look at are the microbiology and geochemistry, the capacity and injection optimization, the geomechanical risks, and the location and techno-economics. So that was in a very short way the research that we are working on. I realized that I had to skip over quite some details. So I'm very happy to answer any questions, or if you want to chat with me, you can always contact me. So thanks a lot for listening.